Okay, hi everyone, how you doing? Today we have another Codeforces round and I'm a little late. So yeah, let's just begin. You're given a string s of length n consisting of characters a and or b. Let a be s be the number of occurrences of string ab in s as a substring. Analogically, ba is the number of this. Okay. In one step, you can choose any index and replace si with any character a or b. What is the minimum number of steps you need to do so that ab equals to ba? Okay. What is the minimum number of steps you need to make to achieve this? Okay, so we don't have to actually tell the steps. Okay, we have to print the string s after the changes. Okay. So if we have a string, we have a, and then we have a b, then we come back to a, then it becomes kind of equal, right? So it has to start with a and end with a. That is what we want. As long as this is happening, then we're done, right? So yeah, so it has to end with the same character. That is what you want. No, but we can have BA, BBB. That can also happen. No, but that would be fine. So the string has to end with both the characters being same. Do we also take the input of, okay, no. If s set I is not equals to s set s. Sorry, this has to be s at 0. Okay, I hope this is fine. Seems like, yeah, this is fine. If there are multiple answers, we can print any of them, fine. So let's just submit this. Cool. Let's move to problem B. So Berlin State University has received a new update for the operating system. Initially it is, and let me just see if my sound is getting recorded. Yeah, it is fine. Initially it is installed only on the first computer. Update files should be copied to all n computers. The computers are not connected to the internet, so the only way to transfer update from one computer to another is to copy them using a patch cable. A cable connecting two computers directly. Only one patch cable can be connected to a computer at a time. Thus, from any computer where the update files are installed, they can be copied to some other computer in exactly 1 hour. Your task is to find the minimum number of hours required to copy the update files to all the n computers. Only one patch cable can be connected to a computer at a time. Thus, from any oh, okay. Fine. And what are they initially telling us? The number of computers and the number of patch cables. Okay, fine. So in one step, we can, we can connect, like, if we have X cables and we have already Y computers which are already having that patch installed, that operating system installed, then we can just include minimum of X comma Y. That is what we can do, right? N equals to 8, K equals to 3. During the first hour, we copy the update from the, okay, and we just find out the number of operations required so that after that, the number of computers don't really matter to us. That is what you want, right? So we have, right, and initially one of the computers is having that OS installed, right? Computer is equals to 1, LL remaining equals to n minus 1. Right. So we need to find the number of steps required such that the number of current computers exceeds k. Right. So we can have this in how many steps? Oh, right. We can like do this properly. So we have while computers is less than equal to k. So we have computers plus equals to computers, and we have okay. Now if remaining is less is greater than 0, then we have answer plus equals to remaining by k. So we'll be taking the ceil value of here. So we'll be doing this. Okay. So this part is like log k, I would say, and then this is like, this is constant time, so this is fine. 4360, yeah. Cool. So this was not difficult, I would say. This was fine. Let's move to C. So in Berlin, n different types of banknotes are used. Banknotes of the ith type have denomination 10 to the power AI. Okay. The denomination of banknotes of the first type is exactly 1. Denomination of banknotes of the first type is exactly 1. Oh, okay. So A1 is equal to 0, right? Yeah. So that is like 10 to the power 0, which is 1. Let's denote Fs as the minimum number of banknotes required to represent S exactly S burls. For example, if the denomination of banknotes are this, then F of 59 is 14 banknotes with denomination 1 and 5 banknotes with denomination 10. What is this 14? Oh, sorry. This is like 14 is the answer here. So 9 banknotes of denomination 1 and fine. And there's no way to do it with fewer banknotes. I mean, I think this is not difficult, I would say. You can choose the maximum one initially, and then you can choose the lower ones. Oh, but the thing is, no, we can always do that. Why? Because like these are multiples of each other, right? So I think we can do that if we do it greedily. Right, then we can do this while k is greater than 0. okay, so this had to be index minus minus. Four 777. Why am I getting 4 here? K is this. What is N? So K is what we need to form, right? So what is 59? Oh, so this, I think this is a different question. I am solving a totally different question. For a given integer k, find the minimum positive number of bills s that can be represented with k or fewer banknotes. That is, fs is find the minimum positive number of bills s that can be represented with k or fewer banknotes. Oh, okay. So I see. Let's denote fs as the minimum number of banknotes required to represent exactly s bills. Okay. For example, if the denomination of banknotes are this, this, and this, f of 59 is 14, which is fine, right? And there's no way to do it with fewer banknotes, right? So this is fine. For a given integer k, find the minimum positive number of bills s that can be represented with k or fewer banknotes. That is, fs is greater than k. Okay, so we have 10, we have 1 here, then we have 10, then we have 100 here. So we want to use 13 notes. Oh, we need to find I'm not sure what this question is asking us to do here. Banknotes of the ith type of denomination this. Fs has the minimum number of banknotes required. Fs is what I'm calculating. Basically, f of k was what I was calculating here, which was not the actual problem. Then they're telling us that that can be represented with k or fewer banknotes. Okay, so if you talk about 13, then 59 can be represented using 14 banknotes. So why are they telling us with k or fewer banknotes? Shouldn't this be okay? So the thing here is that if I'm using a banknote, let's say of denomination 10 to the power ai, let me just write it here, like, so if I have this situation that, I am representing this value x as something like 2 into 10 to the power 100, something like this, plus, sorry, not 2 to the 10 to the power 100, let's keep it like 10 to the power 7, then I cannot have something like 10 into 10 to the power 6. Why? Because I can use this as 1 10 to the power 7, right? So the thing is that if I have, let's say, denomination 10 to the power 9 and I have denomination 10 to the power 7, I can use only 99 of these banknotes, right? For this I can use as many as I like. I don't really care about this. For this I can only use 99. For if I have, let's say, something like 10 to the power 5, then I can again use only 99, because if I use 100 banknotes of this one, then I might as well take 10 to the power 7. So similarly, if I have 10 to the power 2, then I can use 999 of these. right? So let's just define a number that how many can we use here, right? Can use, we can define a vector like this. For the last one, we can make it as infinity. So we have can use at I equals to values at I plus 1 divided by values at I minus 1. Right, these are the denominations that we can, these are the number of banknotes we can use for every denomination. So I can use 9 of these, I can use 9 of these, and I can use infinity of these. Fine. This is fine. Then what do I need to find? I need to find the minimum number which requires greater than k banknotes. Right. So I will be using minimum numbers only, right? And I need at least k plus 1, right? So I can do k plus plus. Okay, 14 I am having. Why am I having 14 here? So I might as well use 9 of these, right? K equals to 0. Oh, this had to be min, right? So yeah, I think this is fine. Cool. Okay, why is it not loading? Also, E seems to have more submissions. Should I go for E or should I go for D? There are n heroes fighting in the arena. Initially, the Ayat hero has AI health points. The fight in the arena takes place in several rounds. At the beginning of each round, each alive hero deals 1 damage to all other heroes. The fight in the arena takes place in several rounds. Initially, the Ayat hero has AI health points. At the beginning of each round, each alive hero deals 1 damage to all other heroes. Hits of all other heroes occur simultaneously. Heroes whose health is less than 1 at the end of the round are considered killed. Okay, at exactly 1 If exactly one hero remains alive there after a certain round, then he is declared as the winner, okay? Otherwise, there is no winner. Your task is to calculate the number of ways to choose the initial health points for each hero AI so that there is no winner of the fight. Oh, okay. This seems to be interesting. The number of ways can be large, so print it modulo this. Two ways are considered different. Okay. So there is no explanation of the sample test cases here. Okay. So if this is the array, then I mean, the thing is that if you look at the maximum numbers here, if I have something like 1, 2, 2 and 3, let's say, okay. So what happens is if you look at it, in the first round, then all of the heroes will have -3, right? Yeah. So this will become -3, this will become -3, this will become -3, this will become -3. So in this way, no hero is actually winning here, which is fine. But suppose I had something like this. This was, let's say, 4. And this was 4 as well. Now what happens is you have again -3, -3. These two are eliminated, but these two remain. So at the end, I mean, it is not necessary to have at least 2 elements equal. The thing is that if you have 2 elements equal in this whole array, if any 2 of them are equal, then it is for sure that there won't be a win. You cannot win, right? Because if you have 2 equal points, then they will always end at the same time, right? So this is fine. If you have 2 elements equal in this whole array, there will never be a case where you have a person winning. But what about the case where we don't have 2 elements equal? That is a good that is the case that we need to consider actually, right? So for 2 and 5, they're saying this 5 ways are there. Yeah, 5 ways. Why? Because both of them have to be equal. If they're not equal, then this does not work. Similarly, let's consider this case 3, 3. Okay, why is Sublime getting opened? Okay, fine. If we consider this case 3, 3, then we can have like 1, 2, 2, and we can like shuffle this and we can have anything. We can have 2, 2, 1. Similarly, we can have 1, 3, 3, and then we can have 3, 3, 1. We can also have this 2, 1, 2, and we have here 3, 3, similarly we have 2, 3, 3, 3, 3, 2, and 3, 2, 3. So these are like 9 ways. These are fine. Here at least one of the elements is repeating. Then we can have 1, 1, 1. We can have 2, 2, 2, and we can have 3, 3, 3. Right? These 12 ways are possible. After that, if we have 1, 2, 3. Why are they saying 15 as the number of ways? For each index, there are like 3 possible points. Then shouldn't it be like 9? Like if all of them are even working? So that there's no winner of the fight. 1 is less. How come we have 15 ways here? There are just 3 elements And even if we assign like anything to any of them, there are how many ways? There are 27 ways. There are not like 9 ways, there are 27 ways here. So if we have then okay, let's try to just consider some cases here. I think for every case where there are two elements equal, that works. But let's like try to find some cases. So we can consider small cases here. We can pass n and k here. Let me just reduce the size. Right. So for every place we have like 5 choices. We have k choices. So how do I handle that? Right, so if z of v equals to n, that means we've considered a case here, and then we just check. If check v, then you just debug v here. Else what do? You just call this helper function again and again. Helper n comma k comma v, and then we do v dot ppv. Right, now we have to check. So we have bool check. Right, so we can probably convert it into a set here, or we can do it like in naively. Okay. So here I'm just like running the brute force thing here to just check what maybe there is a pattern here. So count here b at I . Right, so let's just try out some cases here. Okay. Segmentation fault, okay. Okay, we also have to return here. So I'm getting how many ways? 9 ways. Oh, so we can just remove this part, right? This should be fine then. So I'm having 27 ways here. All 27 seem to be working. Int count here equals to 0. If this is greater than 0, then you increase the count. So if you have 1, 2, 3, then you have -2, -2, and -2. Oh, so this had to be right. Yeah, so I'm getting 15 ways here. 111 is fine, 112 is fine. All the places where at least one element is repeating, that is for sure fine. But what are the other cases here? 323, 313, 333. So these are the cases where at least one element is repeating, right? What about 3,4? So all of these are cases where at least one of the elements is repeating, right? Let's have something like 310. So what about the cases where no element is repeating? Hmm. 5,4. Let's try out this one. Okay, let's just see if there is a case where no element is repeating. Okay, let's try to look at that case. So there is no such case in this part. Let's have something like 5, 6. All of the elements cannot be unique. Is that the case here? Oh, and what about all the elements where at least one element is repeating? Are they all working? That is the question. So for 5,4, it was 1024 as the answer. Let's try out a bigger case probably. Okay, let's make it 8. Let's try this out. So there is no case where no element is repeating, where no element is the same. Okay. What about if we have 3, 10? Okay, at least one element has to repeat, that is fine. I mean, if you have a case where no element is repeating, then I mean, one of the numbers has to be greater than n-1. At least one of these numbers has to be greater than n-1, which is for sure. If that is the case, I mean, it is pretty simple. Like there will be an element remaining at the end. So that does not work out. At least one of the elements has to repeat twice. And can we prove that if any of them repeats twice, then it works? I think we can do that. Yeah, I think we can do that. If any of them repeats, then we're done. So all you have to do is just find out the number of ways where no element is repeating and subtract that, I think. Yeah. So how do I find out that? The number of ways where no element is repeating. So I have n points and k places to fill. So I'll have to first of all find the combination. Right. So I have to choose we have k values, so I have to choose n from that. So I have ways 1 equals to combination. I have k elements, I have to choose n from that. So if k is less than n, okay, let's put it like this: k is greater than equal to n. I have mod 1. These are the ways where no element is repeating. I am trying to find out that. So I will also have to, find out all permutations here. So I'll be doing what about test cases? Do we have test cases here? We don't, right? So n comma k. In fact, we have k to the power n, not n to the power k. And then we have mod 1. Okay, here I'm getting 21. So if two of them are repeating, then it is for sure that you will be having a draw, right? So okay, let's copy this. And let's try to find out the ways that were already there. This had to be t equals to so these are the 15 ways. What are some ways which are not present here? I'm not having 1, 2, 3 at any place, which is fine. Then what else am I not having? 2, 2, 3 am I having? I don't also have 2, 2, 3 here. Oh, we cannot have 2, 2, 3. The element that is repeating has to be the biggest element. That is the thing here. Oh, I see. We have to pick one element which has to be repeating, and that has to be the highest element in that case. Right. Okay, so let's do it like that. We have to pick one element which has to repeat. So I have this current element has to repeat at least 2 times. And if n equals to 1 and n equals to 1 we don't have here. So we have to pick at least 2 elements from this, right? So we can try out always. We have to pick 2 places. So these are the ways where we are picking so many elements, and then we have to okay. The other elements we can fix as we like, right? Yeah. So I is greater than 1. Then I have expo n minus j. Contest error n minus j. N minus j are the places, right? Oh, so we don't really need this. I have expo of I minus 1. Okay. Now I'm getting 12. So the biggest element has to repeat at least twice. Right. So what I'm doing here is that I'm finding j places and I'm choosing this particular element. Right. Then I have how many elements remaining? I have I minus 1 elements remaining. So I'm doing n minus j places are left. So what exactly is the issue here? So I have 3, 2. 3 is repeating 2 times. So how many ways are there? There are just 2 ways. There are 3 ways for that. What about ways 2? Ways 2 is 2, which is fine. Okay. So I have 6 ways as this. Then 3 is repeating, so I have 1 way as this. Then I have 2 repeating twice. This is fine. 2 repeating thrice. Fine. Then I have 1 repeating twice and I have 1 repeating thrice. What are the other ways here? I think this is fine. What if we just repeat only once? No, that is not possible. What are the 15 ways here? Let's see again. I have one repeating thrice, one repeating twice, one repeating twice, then one repeating twice. Okay, one repeating twice here. Oh, so I'm having this element which is repeating only once. This is the case that I'm not checking. Okay. So the elements that are already less than equal to n minus 1. For 2 repeating only once, we can have it from 1 as well, right? Okay, sorry, I is less than equal to. Fine. This is different. One zero two four. Fine. So what was different here? This one. What are the numbers that can only repeat once? For which this could be fine. If the number is like, just a minute. If my highest number is already less than equal to n minus 1, then I am done. This is fine. But let's say my highest number is something like p. Then n minus 1 will be subtracted from it. Right, yeah. So there has to be at least another number from which if we subtract for every number x, there has to be another number y such that y is less than equal to x, such that the number of steps required to remove both of them are same. This is what you want. So we have to decide on 2 repeating elements. I mean 2 elements, and we have to just pair them up. The other elements can be like however they are, but there will be a lot of repetitions in this case. But the thing is that x is the biggest number, right? Y is the other number. So I think then this should be fine. No, but the steps are not just defined by n minus 1. Initially you have n minus 1, then it can also become something like n minus 3. So you will be subtracting n minus 3 from both of them then. No, this does not work out. Initially n minus 1 will be subtracted from both of them. Then it depends on how many elements are remaining now. What is the memory limit here? So I have 500 into 500 into 500. That is not possible. But I can have 500 into 500 type of DP maybe. We are selecting two elements, but we are also concerned about what are the other numbers here. That is also important. Initially, n minus 1 will be subtracted from both of them. That is what we know right now. Then we have to see what is the next element that we will be subtracting. Okay, how about I define my DP? Like if I say that, I have some elements remaining and I'm at the ith step maybe. If there are x elements remaining, and what is the biggest number that has been subtracted till now? If I look at it this way, so there are like 500 numbers, and the biggest number that can be subtracted, like first we subtract n minus 1, then we're subtracting maybe n minus 1 again. So how many rounds will there be? That is the situation. So if I have 500 as my x, 500 as my k, and I have n as something like 2, then there will be at max 500 rounds. After 500 rounds, this has to end. At least one has a hero that. How many steps are remaining and what is the maximum number that we've taken till now? What is the maximum number that we can assign to a certain value? If I say that my maximum value is, let's say, something like 500, what I want is that in the last round, in the absolute last round that happens, at least 2 of the players should be removed. So if I have my last round, then at least 2, like if I have, let's say, n elements remaining, n are remaining, or let's keep it like m are remaining, okay? So if this is the last round, then at least two elements here have to be no, in fact, if this is the last round, then all of the elements are less than equal to m minus 1. That is what we know. M minus 1, m minus 1, m minus 1, right? So there can never be an element which is greater than equal to m here, right? In the last round, there have to be all elements less than equal to m minus 1, and there has to be at least, no, if you're saying that there are m elements remaining in the last round, then all of these elements have to be less than equal to m minus 1. This is one condition. All elements are less than equal to m minus 1 if there are m elements remaining in the last round and m is greater than equal to 2. This is what we want. Okay. What about other problems? Is D having more summations now? No. Okay, what if I define my dp here? Something like dp of remaining, let's call this r, and we have a lower value, let's call this l. So r is the number of elements remaining. L is the lower limit, like this is the lower limit for which all the elements have to be greater than equal to this L. So actually we need to find this dp of n comma 1. This is what we need to find actually. Now if I say that dp of L comma r is what I'm looking for, sorry, r comma L is what I'm looking for, then if I say that, if I say that my elements that are remaining now are also equal to r, then this means that all the lower limit increases by what? Lower limit becomes L plus r minus 1, right? In fact, this will become L plus r, because if I subtract r minus 1 from it, this should not be equal to 0. So the lower limit becomes this, right? Cool. Now if I say this L plus r is greater than k, then this is like dp, this is equal to 0. But then I can also have this situation. Let's say I say that r minus 1 elements are remaining. Then if r minus 1 elements are remaining, then the lower limit again becomes what? The lower limit will become L plus r. That is fine. But I have to select certain elements here. So if I'm saying r minus 1, then I have to select one element which has to be less than equal to this range, which has to be in this range, L plus r minus 1, right? Now if I have something like dp of okay, I think this can be solved using dp. I'm having a very strong intuition for dp here. Let me like write it a little formally here. So I have dp of L comma R. So if R comma, let's have this like remaining and lower. If I say that in my next step remaining elements are only remaining, then I have this dp of remaining lower plus remaining. This is the lower limit that will be there. Now if I say that, you know, in the next step what R minus remaining minus one elements are remaining, then I have lower plus remaining minus one. I mean, this will be lower plus remaining only, but here we'll have to select one element from the remaining, so that will be like remaining ways into, and all of these elements have to be like, this element has to be in between what? Like this is like combination of what? Remaining comma I. Let's have this like I into, and what are the values that you can assign them? We can assign them anything between lower to lower plus remaining minus 1. So that is like remaining minus 1. This will be like exponentiation of this. Now this is the ways where we're selecting, then we have exponentiation of this value, comma I. I think this is what we'll be having here. Remaining minus 1 is the value that we can assign them. These are the values that we can assign them. Combination is like selecting I values from the remaining. Then we have this, which is fine. Then I have this is fine. But what is my base case here? dp of I want that at the end my lower plus remaining should be less than equal to k. We also have one way where we are, you know, removing everything from here, which will be what? Where we are removing everything. So that is like dp of 0 comma remaining. This will be one way. If we have anything here, 0 comma lower, where lower is less than equal to k. This is one. Right, I think this can be done. Okay. dp of so I have initially I have n elements which are remaining, so I'll be having n plus 1, and lower limit is like just 1 here, so right, so we can have the lower limit as equal to k plus 1. Okay, let me like have this normally only. J plus plus dp at ij equals to minus 1. Right, so what was our base case here? If Also, if like n equals to 1, if we have only one element, then you return 0. If lower is greater than k, you return 0. If okay, this is not the case that you're looking for. If n equals to 0, that means all of them were removed. Then you return 1. And we also check this. If dp of n comma lower is not equal to -1, then you return. Now we do for every case here. Right. Ways to pick equals to combination of. So from n elements, I am going to be picking up I elements, and mod 1. Ways to pick are these. Then for every element, ways to assign equals to exponentiation of we have what we have, like remaining -1, right? What was remaining here? Oh, we can assign them any value here, right? Here. Okay, n minus 1, and I have I. Mod null ways to pick, ways to assign, and I have lower plus -1. I think I can sort of optimize this part. Combination is fine, mod null is also fine, I think. Okay, let's try out this here. Okay, so dp is not defined here. Okay, let's define it above. Helper, I'm having also we need to send k here. This is also different from what the answer is given. Zero ways here. Okay, so If n equals to 0, that means we are removing everything in one go. That is fine. Is not equal to -1, then we do this. Ways to pick is combination of n. From n elements, I'm picking up I elements. Okay. Picking up I elements here, and then I'm doing ways to assign. These are the numbers that I'm assigning them. So what is this n-1? Like, this is the range, right? Yeah. Ways to pick, and I are the elements that I'm picking, so this is fine as well. Ways to pick into ways to assign into helper of n-i. Yeah, n-i elements will be remaining here. Lower plus n will be the new lower limit. I don't know why this is not working. Let's try out 3, 3 here. Okay. So I have 3. Okay, I'm having 0 here. So let's try to debug this. So I have 3, 1, fine. Then I have 3, 4. This is 0. Then I have 2, 4. Because like if 2 elements have to remain, then the lower limit is now 4. Okay. I think this has to be above this. Okay, I'm getting 8 now. Ways to pick is combination of n, I. So if I want only one element to be remaining, then my next lower limit is 3. Why am I having lower plus n? Like initially the lower limit is 0, right? Now I'm having. No, the initial lower limit is fine. This is the initial lower limit. Then if I'm already greater, then this has to be n-1. Okay. This had to be mod add, right? Yeah, now this is fine. So if I have n as 3 and the lower limit is 3, then how come I have 8 here? N are the number of elements remaining, and my current lower limit is 8. So the number of ways are not n minus, this is not the thing. The number of ways are we can only reach till k, right? So that's like k minus okay, now this is coming out to be fine. Finally. Okay, so I only have 3 cases here. No, I also have this one. Right, this is fine. What if I have n as 1 only? Fine. Let's submit this. Wrong answer on test 1. Okay. So I had to submit e.cpp, not c.cpp. Okay, I'm glad it did not work on the first test case. Okay, great. Fine. I'm not sure if like I can do D as well now. It has like a very few submissions. Okay, let me just read D for now. Let's see if it is somewhat doable.